Now we move to the next topic. Okay, discusses about inequalities. So in the previous topics, we discusses about equal expressions. That means left hand side equal to right hand side. Okay, the expression at the left hand side equal to the expression at the right hand side. Now we discuss about the situation where the expressions not equal. Okay, the left hand side not equal to the right hand side. So that is what we call as inequalities. Okay, the following are the learning outcomes. Okay, now we consider the following situation. For my mother's birthday, I would like to buy a chocolate cake. Okay, I'll buy a chocolate cake and a cheesecake. The price of the chocolate cake is less than half of the price of the cheesecake. The question is, how can we express this problem mathematically? Okay, in order to do that, we need to use mathematical notations. Okay, so the first step is to denote the price of the cheesecake as X and to denote the price of the chocolate cake as Y. Okay, so based on the given equation, the price of the chocolate cake is less than half of the price of the cheesecake. So we have this what we call as inequality because it is not equal. It is less than y less than half of x. Okay, so we have y less than 1 over 2 times x. So this inequality, okay, so we can rearrange this inequality and come out with this form. We take 1 over 2x to the other side, so we come out with this inequality. So this is known as linear inequality because the highest power for the x is equal to 1. The power is 1, so that's why we call it as linear inequality. Okay, so we consider the following properties of inequalities. Okay, if A is less than B and B less than C, then A is less than C. Okay, you can see the example. If A is less than B and C is any number, okay, C is any number, so then A plus C is less than B plus C. So what does it mean? That means if we add this inequality with one number at both sides, okay, so this sign remain the same. Okay, it remains the same sign. So we have A plus C less than B plus C. So you can see the example here. Next, if we have A less than B and C can be any number, so just like the addition, we also can subtract one value at both sides. Okay, for example, C, we subtract C for the both side, A minus C, B minus C. So the important point here is this inequality sign is remain the same. It remains the same sign. Okay, it is still less than. So we have A minus C less than B over C. Okay, you can see this example. All right, next, for the next property, if A is greater than 0 and B is also greater than 0, so A plus B equal to 0. Okay, next, if A is greater than 0 and B is greater than 0, so just like the addition, for the multiplication also, the multiplication of A and B also greater than 0. Okay, if A is positive, B is also positive, the multiplication of positive and positive number come out with positive number. Okay, but then, okay, next, if A is less than B, then B minus A is greater than 0. Okay, because A is smaller than B, so B minus A is greater than 0. For A minus B is less than 0 because A is smaller than B. Next, if A is greater than B, then, okay, negative A is less than negative B. So the important point here is this sign. Okay, because the A and B becomes negative, so we change the direction of this inequality, so it becomes less than. Okay, previously it is greater than, now it becomes less than. Okay, for the next property, if A is less than B, Okay, the original one is less than b, but if a and b becomes negative, so we need to change the direction of this sign. So it becomes greater than. So negative a greater than negative b. So you can check the example to verify this property. The next property, if a is less than b, and we have another number c, but the value is positive. Okay, we have c is positive value. So if you multiply c to the inequality, this inequality to both sides, so this sign remain the same. Okay, so originally we have a less than b, then we multiply with positive number c at both sides, then we have ac less than bc. Okay, you can see this example. Okay, again, if we have a less than b, then we have another number, but this time the number c is negative. It is less than 0. So if we multiply c to both value a and b, so now the direction of this sign change. From less than, it becomes greater than. Okay? It becomes greater than because c is less than 0. Okay, so just like in the previous slide, okay, this situation, originally we have a greater than b, but then we multiply both with c equal to negative 1. Okay, negative 1, so it becomes negative a. We need to change the direction, it becomes smaller than negative b. Okay, alright, so same goes with the properties number 8. Okay, now we have a summary of set, okay, set, and also summary of interval notations, okay, together with the graph. Okay, so if we have x greater than a, so how to express this one in interval form? That means we have an open interval from a up to positive infinity. So we need to use the open interval because it is greater than. Okay, greater than sign, so we need to use open interval. So how to graph this interval? So this is the graph. We have a, so we need to use this white circle, and the direction is moved to positive infinity. Okay, the second one, we have x is greater than or equal to a. So how to express this one in the interval form? So it becomes, we have to use this square parenthesis from a because it is including a. So from a up to positive infinity, at the infinity we need to use open parenthesis. So we have in this graph, this is the form. Okay, we have the a, so we need to use this solid circle, okay, instead of the white circle because we are dealing with closed interval. Move from a up to positive infinity. Okay, next we have x less than a. Again, this is an open interval from a up to negative infinity. Okay, negative infinity at the left side and a is the right side. So we have this parenthesis. So how to draw the graph? This is the graph from a. You need to use this white circle because it is an open interval. It moves from a up to negative infinity. Don't forget about the direction of this arrow. Okay, next is x less than or equal to a. That means now it includes a, including a. So we need to use this square parenthesis. Okay, so in the graph form, we need to use this solid black circle. Moves from a up to negative, down to negative infinity. Okay, now we have the following notation. We have x is greater than a and less than b in set form. So to transfer the set form to interval form, we have this open parenthesis. Okay, square parenthesis to indicate this is an open interval. Okay, so excluding a and b. So in the graph form, so we need to use this white circle to indicate this is an open interval, excluding a and b. So on the contrary, for the x is greater than or equal to a and x is less than or equal to b, so we need to use this square parenthesis because this is a closed interval between a and b, including a and b. So we need to use black solid circle to indicate this is a closed interval from A to B. Okay, so now we move to the next one about linear inequalities. So linear inequalities can be written as follows. Okay, so we have the following four inequalities. So what is the similarity? The similarity is, okay, the highest power for the x equal to 1. Okay, that is why we call it as linear inequality. Okay, the highest power of what is 1 because the value is 1, so I don't need to write the power. Okay, just write the x. So we know the power is equal to 1. So we have ax plus b greater than 0, greater than or equal to 0, less than 0, and less than or equal to 0, where a and b can be any real number, and we need to make sure that a not equal to 0 to maintain the linearity. Okay, we need to make sure x remain there, so we need to make sure that a not equal to 0. Otherwise, the remaining value is b lah. Okay, so it's no longer a linear inequality. Okay, we consider the following example. Solve the following inequalities. Solve means we need to find the value for the x. Okay, so we have 2x minus 4 greater than 8. So we use the properties of inequalities to solve this inequality. Okay, first of all, we have 2x minus 4 greater than 8. So our first step is to eliminate negative 4. How to eliminate that one? That means we want to make it 0. To make it 0, that means we need to add 4 to negative 4. Okay, in order to keep this inequality remain true, so we need to put plus 4 at both sides. Okay, according to the inequality property, so this sign remain the same direction. Okay, so we add plus 4 at both sides, so we have this one becomes 2x. Okay, because this one equal to 0, so we have 2x. At the right hand side, we have 12. Now our interest is to know what is the value for the x. So in order to eliminate 2, we need to multiply both sides with half. Okay, again, because we multiply with positive number, okay, because half is greater than 0, so this sign also remain the same direction. Okay, so now after we multiply with half, so we come up with x is greater than 6. That is the answer or the value for this, the value for the x that can satisfy this inequality. So in the set form, this is the solution. The value for the x is greater than 0. Or we also can express the answer in interval form. So we have this open parenthesis, okay, open interval using the square parenthesis. Okay, all right, so we also can verify actually our answer. Okay, we also can verify okay, to check whether the x is truly greater than 6 is truly solve the given inequality. So we take one value that is greater than 6. For example, we take x equal to 7. Okay, we insert x equal to 7 into the given inequality. So at the left hand side, we get the value of 10. 10 is obviously greater than 8. Okay, 10 is greater than 8. So it's true, when x is greater than 6, it can satisfy these inequalities. It can make these equalities true. Okay, now we move to the second one. We have 4x minus 5 less than 2x plus 9. Again, the task is to find what is the value for the x. Okay, so in the first strategy is to eliminate the negative 5. Again, to eliminate negative 5, that means we need to add 5 at both sides. Okay, so based on the inequality property, so these remain the same. Okay, so this one becomes 0, so we have 4x. Okay, so at the right hand side, we have 2x plus 14. Next is to take the next task is to eliminate 2x at this side. Okay, how to eliminate 2x at this side? By subtracting, okay, with negative 2x at both sides. So we take negative 2x at this side. We also put negative 2x at the right, at the left hand side. Okay, so because this one 2x minus 2x equal to 0, so the remaining value is 14. At the left hand side, it becomes 4 minus 2 equal to 2x. Okay, now it becomes easier for us to solve for x. We just simply multiply with half at both sides because half is greater than 0, so this sign also remain the same. So we have x is less than 7 as the answer. So again, we can verify it. We can take one value less than 7, for example 6. We insert into the inequality to see whether the inequality true or false. So if we after we insert x equal to 6 into the inequality, it remains true. Okay, so it's verified. Okay, now the third example, 3x plus 5 greater than or equal to x minus 7. Okay, so again, when you want to eliminate positive 5, that means we need 2 minus 5 at both sides. Okay, so it becomes 3x greater than or equal to x minus 12. We eliminate x did at these sides, that means we need to minus x at both sides. Okay, so now it becomes 0. The remaining value is negative 12. At the left hand side, 3x minus x equal to 2x, so we have this inequality. 2x greater than or equal to negative 12. So it's very easy how to eliminate 2 by multiplying both sides by half. Again, because half is greater than 0, so it remains, we maintain the inequality sign. So it is x greater than or equal to negative 6 as the answer. You also can verify the answer. Okay, and the third one, okay, and the next one we have 2 minus 3x greater than negative 7 and less than 8. Okay, how to solve this problem? So the first strategy is by eliminating 2 in the middle. So how to make it possible? We need to deduct 2 at every item. Okay, we minus 2 here, minus 2 here, minus 2 here. Okay, so we simplify, we come up with this inequality. Okay, now we want to eliminate the negative 3 at x. So that means we multiply all items by 1 over 3 because 1 over 3 is positive, so this sign remain the same. Okay, so after we multiply, so we have this inequality. Okay, we have negative x is greater than negative 3, less than 2. Okay, so our aim is to find x but not negative x. So what does it mean? That means we need to change negative x becomes x. How to make it possible? We multiply each item by negative 1. So this time, we multiply with the value that less than 0. So what does it mean? That means we need to change the direction of this inequality. Okay, so for this one, originally it is less than, so now it becomes, okay, for originally it is greater than, so it becomes less than. Same goes with this one. Originally it is less than, so it becomes greater than. Okay, so x is become this one, so we can change to the standard form. So we have x is greater than negative 2 and less than 3 as the answer. So the key point here is here because you multiply each item with a negative value, so we need to change the direction of the inequality. Okay, so this is the answer. The value for the x that satisfy this inequality is x is greater than negative 2 and less than 3. This is in the set form, this is in the interval form. Okay, so finish with the linear inequalities, we move to the quadratic inequalities. So what is the difference? Again, the difference is the power for the variable x. Previously, for the linear inequality, the highest power for the x equal to 1. But this time, the highest power for the x equal to 2. That is why we call it as quadratic inequality, because we have inequality sign here. So in order to maintain the quadratic form of this inequality, so we need to make sure that a not equal to 0. Okay. All right. Okay. For how to solve a quadratic inequality, so we can use what we call as graphical method. Okay. So how to do the graphical method? We need to consider the given quadratic expression as equation like this. Okay, we make it as y equal to x squared plus bx plus c because we want to plot this, we want to sketch this equation in the form of graph. In the graph, we have y-axis and x-axis. So that is why we need y and x. Okay, so the graph of the quadratic equation is sketched and points where the graph cuts the x-axis. Okay, cuts the x-axis, that means we want to find the value for the x when y equal to 0. Cut at the x-axis means when the value of y, okay, y equal to 0. Okay, so we get these two values p and q when the value for the y equal to 0. Okay, so let's say p and q noted, so we have the following graph. So what happens if we take x equal to 0? So x equal to 0 will give you the value of c. So where is c? C is here. Okay, this is the value for the c where x equal to 0. Okay, you can replace x equal to 0 to this equation. So the remaining value is c. C is this point. Okay, for the graph, okay, we look at the value for the constant a. Okay, if the constant a is if a is greater than 0, so the graph is in the form of smile form. If value for the a is less than 0, so it is in the sad form like this. If happy, it is like this. Okay, smile and sad, it depends on the value for the a. Okay, so from this graph we have the following information. Okay, we can interpret from this graph the following information. This is the graph when the value for the constant a is greater than 0. We have a smile form. Okay, so this graph cuts the x-axis at 2 points p and q. Okay, so what information that you can get from this graph? Okay, for when y is greater than 0, so where is the area when y equal to 0? Okay, referring to the graph, where is the y? Y is here. Okay, so y is greater than 0 means we need to consider this area. Okay, this area above the x-axis. That means the y is greater than 0. Where is the area when y is less than 0? So the area is below the x-axis because this goes to negative. This graph goes to negative y. Okay, so this area, okay, this one is for y greater than 0, and this area is when y less than 0, below the x-axis. Okay, so from the graph, when y is greater than 0, that means we consider upside or above the x-axis. So we have which area? We need to use different color. Okay, which area? So upside or above the x-axis, we have this area covered by the graph. Okay, so this area represented by x is less than p. Okay, it is less than p, and x greater than q. Okay, it moves to this direction. So the red area covered by red area represented by x less than p, and also x is greater than q. So that is the value when y is greater than 0. When y is less than 0, so we consider the area below the area covered below the x-axis. So where is the area? This is the area. Okay, below the x-axis. So the area is between p and q. Between p and q. Okay, so the value for the x is greater than p and less than q. Okay, that is the case when a is greater than 0. So now how about if a is less than 0? So we have this sad form graph. Okay, so again, this is the area when y is greater than 0, and this is the area when y is less than 0. Okay, so when x is greater than 0, so where is the area covered by the graph? This area. Okay, so this area, so that means the value for the x is between p and q. So x is greater than p and less than q. Okay, so for the when y less than 0, so where is the area covered by the graph? This area, okay, and this area. So that means the value for the x are less than, okay, it move to this direction, so x less than p, and it moves to this direction, that means x is greater than q. Okay, all right. Now we consider the following example. By using graphical method, find the set of values for the following inequalities. Okay, in other words, find the value for the x, okay, for the following the given inequality by using graphical method. So now the question specified the method that you need to use in order to come out with the answer. So you need to answer the question. That means that you don't have any option. You need to use graphical method. So let's say you come out with different method. Okay, use different method but come out with the correct answer. So what happened? So you are considered as not answering the question because the question asks you specifically using the graphical method. So you need to answer the question. Okay. So what does it means? Okay, by using graphical method, what is the first step? Okay, so the first step, we need to find the value for the P and Q that intersect the x-axis. So how to find P and Q? So we need to let the given expression as y. Y equal to x squared plus 6x plus 5. And then in order to find P and Q, we need to let y equal to 0. So we solve for the x. Okay, so we have y equal to x squared plus 6x plus 5. So we let y equal to 0 in order to find P and Q. So we have this equation. So this equation can be factorized, becomes x plus 5, x plus 1 equal to 0. So we solve for the x. We have two values, x equal to negative 5 and x equal to negative 1. Okay, so we can take this one as P, this one as Q. Okay, so now we can sketch the graph. Okay, sketch means no need to be exactly correct graph. Okay, we just need to know the curve, is it smile or sad, and also the intersection point. That is what we mean by sketch. Okay, sketch the graph. So because the constant for the x is equal to 1, 1 is positive, so it is in a smile form. And then we have two intersection points. We have negative 5, we have negative 1. Okay, because negative 1 is greater than negative 5. So we put negative 1 at the right hand side and negative 5 at the left hand side. Alright, so now note that, okay, now our interest is to find x when the following expression is greater than 0. Okay, previously we just denote this one as y. So that means we need y is greater than 0. So back to the graph of x and y graph. So y greater than 0 means the area above the x-axis. Okay, the area above the x-axis. So where's the area? The area is this side and also this side. Okay, so clearly we have two values of x. We have x is, okay, x is less than negative 5 and x is greater than negative 1. Okay, for the shaded area, we have two values for the x. We have x is less than negative 5 and x is greater than negative 1 as the solution. So we put the solution in the set form. So we have this two sets. Okay, set x, the first one, x is less than negative 5, and then we combine because we are combining two sets, so we have union. Okay, union of x where x is greater than negative 1. So this is in set form. Let's say the question want you to represent the answer in interval form. So this is the answer in the interval form. So we move from negative infinity up to negative 5. Open interval because we use this sign. Okay, and then at the other side we have union with negative 1 up to positive infinity. Again, it is open interval because we have this sign. Okay, so that's the complete the answer for this question. Okay, next, we are given different inequality, but again we need to use graphical method in order to solve this inequality. Okay, so just like the previous one, we let the given expression as y. Okay, y equal to negative 3x squared minus 7x plus 6. Okay, so make sure you rearrange the expression in the standard form. Okay, we have negative 3x squared minus 7x plus 6. Why? Because we want to correctly identify each constants. Whereas the A, B, and C. So now we want, especially in this case, we want to identify our A. So our A is negative 3. That means our A is less than 0. That means when we sketch the graph, so the graph is in the said form. Alright, so now we have the equation of y. The next task is to find the intersection point at the x-axis. That means we need to assign y equal to 0 and solve this equation. Okay, so this is the factor. So if we solve for x, we have two values as the intersection values. So we have this one and this one. So because negative 3 is smaller than 2 over 3, so we can take x equal to negative 3 as p, this one as q. Okay, put in the graph. We sketch the graph because this is a set form. So we have this graph. So we have two intersection point. Okay, negative 3 at the left hand side and 2 over 3 at the right hand side. So now we want to consider which area is covered by this inequality. So back to the inequality, we're given that this inequality is less than 0. That means our interest is the area below the x-axis because this is when y is less than 0. Okay, y less than 0. So the area below the x-axis, we have these two areas. Okay, this area and also this area. So for this area, it is moved to negative infinity. This one moved to positive infinity. It move from x is greater than 2 over 3. It moves from x is less than negative 3. Okay, so we combine together, so we come up with this set of solution. We also can represent the solution in interval form. Okay, another question. Okay, using the same method. Okay, so first of all, we are given this kind of inequality. So remember, our aim is to write this inequality in the standard quadratic equation form. Ax squared plus bx plus c. So that means you need to rearrange this inequality by using algebra. You need to rearrange it algebraically. Okay, so how to do it? So we expand. Okay, we have 3x squared minus 15x at the left hand side. At the right hand side, we have 4x minus 6 after we expand this to multiplication. Okay, so now from here, so we take all the values at the right hand side to the other side. So we have this inequality. We have 3x squared minus 14x minus 4x, which can be simplified, becomes negative 16x plus 6. 3x squared minus 19x plus 6. Now it becomes easier for us because we can assign this one as y equal to 3x squared minus 19x plus 6. Okay, again, because we are using graphical method, we need to sketch the graph. We identify the value for the a equal to 3. 3 obviously greater than 0, so it is a smile graph. Okay, and then we let y equal to 0, so we have this equation, and then we factorize. We come out with these two intersection points. We have 1 over 3 and 6. Okay, because this one is smaller than 6, so we have this one as p, this one as q. So we put in the graph form. So this is the graph form. We have two intersection point. It is smile graph. Okay, so back to the question. The given expression is less than or equal to 0. Okay, less than or equal to 0. So where is the area? The area is, less than or equal to 0. That means the area is below the x-axis because y is less than 0. Okay, because it is actually y less than equal to 0, because we let 3x squared minus 19x plus 6 equal to y, right? So we have y less than or equal to 0. Okay. So the area, where is the area? So for the y is less than or equal to 0, the area is covered by this area. Okay. So we have the value in between 1 over 3 and 6. Okay, so the value for the x is because we are dealing with less than or equal to, so we need to use this sign as well. Okay, x is greater than or equal to 1 over 3, and x is less than or equal to 6 as the answer. So you need to represent the answer in set form. So you enclose the answer in this parenthesis. Okay, x is greater than or equal to 1 over 3, less than or equal to 6. Or also you can represent the answer in interval because we have less than or equal to. So we need to use this square parenthesis because it is it is a closed interval. Okay, that is the answer.